Hey guys, it's Alex with Engineering Applied. In this video, we're going to be taking a look at the available 2D sketch constraint tools available in Autodesk Inventor. If you're looking for a particular function, check the description for timestamps. And if you don't find what you're looking for in this video, go check out my other videos in my Autodesk Inventor tutorial series because I'm confident you'll find exactly what you need. Also, don't forget to like this video, subscribe to the channel, and turn on notifications so you don't miss out on any helpful content like this in the future. Let's get started. Okay, so to get started here, we're going to be taking a look at our dimension tool. And I have a few shapes drawn up here because I want to show you the various dimensions that this one tool can create for us. So starting here on the left, we have a circle. So if we just click dimension and then click on the outer profile of the circle, we can constrain its diameter. So let's constrain this to 1/4 of an inch. Or we can also constrain its location to a interest point or a reference point. So in this case, I want to use the origin. So I still have dimension pre-selected. So I'll just select the center of the circle. And then I'm going to select this origin here. And you could see we could set the vertical distance or we could set the horizontal distance to the origin. So we'll go ahead and just leave that as is. And then we'll go ahead and set a horizontal distance. Okay, so now our circle is fully constrained. Next, we can do a couple of things with lines within a profile. So here I have a rectangle drawn up. We can either give a length to a leg of a profile. So in this case, we can set the length of this vertical leg. So we could set that to, we could set that to 0.4. Or we could set a distance. So what we could do is we could set the distance between this horizontal leg and this horizontal leg, and it'll give us the same effect. However, we picked up two separate segments to do this. So that's the difference. The first option that I did here on the left, that was a length. This next way of dimensioning is a distance. Okay. Next, we can also set an angle. So what we can do is we make sure dimension is toggled, and then we can come over to this shape over here, and we'll just set the angle between these two lines. So say I want to set it to 35 degrees, I can do that. Additionally, we can also pick up endpoints of a line. So if I were to draw a line out in space somewhere here, I could actually go to dimension, pick up the two endpoints, and then it'll give me a distance there between the two endpoints. The next constraint tool we have is the auto constrain tool. And so in this particular case, I have a rectangle drawn up somewhere out in space. And then I also have a point fixed at the origin. So what we can do here is we can auto constrain a profile that's found in our sketch plane. So we click auto constrain. And then if you look in this dialog box, we have our first option, which is our curve selection tool. So we'll just select the curves that we want to auto dimension and constrain. You'll notice we have two checkboxes here. One is to make sure that we're auto dimensioning, and one is to make sure we're applying constraints. And you'll see that, hey, we have 4 dimensions required to fully define the shape. Now, what you'll notice is if I hit apply, it'll add the vertical and the horizontal leg lengths, but it's still blue and it says we still need 2 dimensions. That's because this is still free floating in space. So if I click done, I can still click it and move it in the vertical direction, and I can still click and move it in the horizontal direction. So if you're ever unsure if something is not constrained fully or in which direction it's not constrained in, just grab your profile and click and drag it somewhere, and that'll give you some insight into what needs to be constrained. So let's go ahead. We're going to undo this, and we're going to highlight auto constrain again. We're going to pick up the profile. But we're also going to pick up the point here. And let's say this is where we want the rectangle to stay out in space. So we've got all of our reference geometry and our actual geometry selected. We click apply. And now you'll notice that our rectangle is black. And that means that everything is fully defined in this sketch. So we have our vertical dimension, our horizontal dimension, and then we have our actual location of the rectangle out in space defined as well. Now we can actually go back and re-dimension things as necessary. So I could change that to 0.4 if I wanted to say. So now we have a fully dimensioned rectangle out in space, and that's how you use the auto dimension and constrain tool. The next function is the show constraints button. And so what this basically does is it shows us all of the applied constraints that are found in our sketch geometry. So if I click this, and then highlight everything, you'll notice that in these shapes I have drawn up, it tells me what constraints are being applied to these profiles. So starting on the left here, I have an arc that is constrained as concentric to this circle. So basically it means that the center point of this arc is coincident with the center point of the circle. Now moving over to the right, we have a rectangle, and you'll notice these little two lines that are moving up at an angle side by side. This is the parallel constraint. And you'll also notice that you have these two lines horizontal that basically says that, hey, this is a horizontal constraint. And lastly, you have this perpendicular constraint at the corner. So with all of these constraints applied, this tells the rectangle that, hey, I have two vertical legs, two horizontal legs, and then everything is 90 degrees from one another. If we want to hide the constraints that we've shown, we can highlight everything, right click, and go down to hide all constraints. And you'll see the shortcut here once you have this menu open is F9. So we could just click hide all constraints. And then there we go. Now all the constraints are hidden again. We can freely grab the corners, the endpoints of our profiles, and manipulate it as needed. Next, we have our constraint settings menu. So if we go into this menu, we can play around with our constraint settings, change our inference settings, and enable and disable relax mode, and then edit what gets removed when we enable this mode. So what relax mode does is if we go to this fully defined rectangle and we try to click and drag the lines, it doesn't move because it's already fully defined. There's no movement left in this. So what we can do is we can go to constraint settings, relax mode, and enable it. And these features that I have checked off here will be removed in this mode. And so when I go to this rectangle and click and drag again, it removes those constraints. So like the horizontal constraint, some of the parallel constraints, and then I can click and drag this and move it wherever I want. And then it removes them all together when I'm done. Okay, now we're getting into the individual constraints themselves. So the first one we're taking a look at here is the coincident constraint. So in this case, let's say I've already dimensioned the diameter of my circle and I want to set the center point of the circle coincident with the origin. So what I can do is I can click my coincident constraint, and then I can go to the center point of the circle, click that once. And since I want to constrain it to the center point of the origin, I can go to the origin dropdown folder here in my model tree, and I could just go to center point and left click on that. And then it'll snap it to the origin itself. And now you see we're fully defined. We can also manually put down a point. So what I'll do is I'll just undo that, and I'll just manually put a point somewhere in space. And let's say I'll just go ahead and fix this here because that's where I want it. And then I can go back to coincident, click on the center point, and then click on the point, and then it'll snap it to that area. Another example for the coincident constraint is, say in this case, I want the endpoint of this line to be coincident with this line. I just have to click coincident there. I can click on the endpoint, and then I can click on the line itself, and it'll drop it there. Now we're at our parallel constraint. So in this particular case, I've drawn up a shape somewhere out here in space, and I want this angled line to be parallel to this line that I've constrained here. And we'll actually go ahead and make this a construction line. So what we can do is we can click parallel, click the first line, and then click this line, and it'll set the two parallel. What we can also do too is I can pre-select the two lines first by holding down Control and then clicking both of them, making sure they're both selected, and then I can go to parallel constraint and then click that, and it'll apply the constraint as well. Now for our tangent constraint, in this particular case, I want to set this line tangent to the circle. So I went ahead and fixed the line out here in space so that the circle will move to it. So what we'll do is we'll go ahead and click tangent, click either the line or the circle, it doesn't matter. So we can click the line first and then the circle, or we can go back and click the circle first and then the line. And then that sets the circle tangent to that line. Okay, so the next tool is the collinear constraint. And so the collinear constraint, all this does is it sets two line segments. Collinear, which basically means that it's on the same line. So if two lines are out in space, I can bring one down to be collinear with the other. So here I have an example of a shaft that I want to revolve around the x-axis. Before I revolve this, I need to set a constraint so that this is collinear with this, regardless of whatever dimension or height I make this here. So basically all I have to do is go to collinear, click on the one segment, click on another segment, and then it sets it collinear, and then now I'm defined in that direction. And you'll notice if I change this dimension here, let's say we change it to 0.425, this line travels with it. And this is a good practice to make your design more efficient. Next, we have our perpendicular constraint. This is very simple. So basically this sets two line segments within whatever profile you have drawn up in your sketch plane to be 90 degrees from one another. So let's just say we're drawing some sort of set of line segments. It doesn't matter what length they are for this particular example. I just want these two line segments to always be 90 degrees with respect to one another. So I just go to perpendicular and then click this line and then click that line, and then it sets it 90 degrees to one another there. Next, we have our smooth constraint. And so for this constraint, I set up two horizontal lines and then an interpolated spline between the two with a single somewhat middle point. It's not perfectly middle to the arc, but it's not important for this case. So what I do is I go to smooth, I click on this line and then the spline, and you'll see it sets the end, or I should say the beginning of this spline here in line with that first line. But you'll notice down here, we're still going in at an odd angle with reference to this line. So what we'll go ahead and do is we'll go ahead and click on the curve and then click the line that we want to smooth it to. And then there we go. It smooths out that spline to be in line at the endpoints with this geometry that was previously drawn up. Next, we have the concentric constraint. And so what we could do with this is we could set two circular elements concentric to one another, meaning that their center points will be coincident. So in this case, I have a profile drawn up where I performed a fillet on these two top corners up here, and I just want to constrain this circle concentric to this arc here. So I'll just press this concentric constraint button up here, select the circle, and then select the arc, and you'll see that it snaps the circle concentric to that arc there, and I can use this to perform a cut through the part or whatever it is that I'm doing here. Okay, next I'm going to bundle in the horizontal and the vertical constraints together. So I have a profile drawn up here. There's no particular rhyme or reason to the angles or anything like that, but essentially I want to create a rectangle out of these random lines that are on the screen here. So the first thing I need to do is I need to set the top and the bottom legs horizontal. So what I'll do is I'll go to the horizontal constraint. I'll click this line. It'll set the top line horizontal. I'll do the same for the bottom. And there it goes. It sets that horizontal as well. Then I'll go to the vertical and I'll just set that vertical and that one vertical. And now I have my rectangle. Okay, so next we have our symmetric constraint. So in this case, I have three separate line segments, but they're all joined by a single point. And this angle inside here is different from this angle. This angle is larger. And what I want to do is I want to create some symmetry around this vertical line. So I want this angle and this angle to be the same and the whole thing symmetrical. So what I can do is I can click symmetric. I'll select one leg, and then I'll select the second leg that I actually want to change for the symmetry. And then I'll select the third line in which I want to make this whole thing symmetric too. And then there we go. Now we have a symmetric shape, and then we could go back and dimension these line lengths or whatever else we got to do there. Okay, so next we have our fixed constraint. So the fixed constraint is extremely simple to use. So all you do is you click the little lock icon here for fix, and then we just click all of the sketch elements that we want to fix in space. So we could click anything from rectangular shapes to circles to line elements, whatever it is that we have there, and you'll see it locks them into place. And now if I go to click and drag these, they're not going anywhere. So this is helpful if you're drawing up a concept real quick, you're not really interested in dimensioning the whole thing, you just need to lock something in space real quick, like a little point or something like that. This can be useful for that. Okay, so we have our equal constraint here. And so what this does is it sets various types of dimensions equal to one another depending on the scenario. So in this case, I have a rectangular profile. And the first thing I want to do with this is I want to set all of the circles equal to one another. So I have the first one dimensioned to 1 inch in diameter. So I'll go to equal, I'll select the first circle, and then just start selecting the first circle and then the subsequent circles that I want to match to it. So I've got that one done. I can go down here and lastly get this last one. And now you'll notice that I've drawn a line segment from each corner to the center point of each circle. And I want to set these line segments equal. So what I'll go ahead and do is I'll set a dimension for these lines here. So I'll just go ahead and set this one to whatever it happens to be. And then I'll set all of these other line segments equal to that. So I'll click the first line and then click this line and then go through and do that for the rest of them here. Picked up the wrong line there. If you're having trouble picking up a particular profile, you can hover the mouse over the general area of what you're trying to get, and then a little drop down will pop up like this. You can go to the drop down here, and then it'll highlight whatever it is that you can select. So I'm going to go down to this number 2 option, and now I've got that curve, and now I can set it equal to that. And then lastly, we could do this one, and there we go. Now we have all of our little line segments set to the same dimension. And you could apply this in all sorts of scenarios. This is really useful for boosting the efficiency of your design so that, let's say, for example, I want to change 1 diameter and not 4 diameters. I can do that. So I can just double click on this and say I wanted to change it to 1.25. It changes everything all at one time. Okay, so our next constraint tool is our edit coordinate system. And to get here, you just pull this little drop-down menu open, and you can tell there's a drop-down menu there by that little arrow, and you click edit coordinate system, and you'll notice I created a 3D body of just some arbitrary shape, because what we can do is we can edit the native coordinate system found when creating a sketch on a plane. So in this case, I'm creating a sketch on this plane. So if we look normal to that, we see this is our default origin location, and you can see the axis coincides with this one point on the vertex here of the shape. But let's say I want to move the origin up to this point up here. What we could do is we can click and hold on that point, and then we can drag it up until it stops. And what you'll notice is once we double click there, the axis is now frozen here. To validate this, all we do is right click and go to OK, or you can press the enter key. And now you notice that the origin has shifted up to that point that we told it to. Now, if we undo that, we can go back down, and we can also do another type of translation of the coordinate system. So we go back to edit coordinate system. And let's say I want to change the x-axis to be in line with this angle here. So what I do is I click the little red leg, which is the x-axis, and then click this part feature here on this angle. So we'll click that. And now you'll notice the x-axis is in line with that. And then if we go to OK, the coordinate system has shifted to now be in line with that. So this is really handy if you're trying to create some eccentric geometry that is referenced off a different set of origin directions. Okay, so the final tool that we're going to be taking a look at in this session is the Constraint Inference Scope. And so what this allows us to do is it allows us to control what geometry is used to infer constraints when creating new geometry. So what does this mean? Well, when we open this command, we see 3 options here. By default, it has the geometry and current command selected. So what we're going to go ahead and do is I'll start out by drawing a couple of lines. So we'll just set the first one down. It doesn't matter where. And then we'll go to create a second line. And I want you to pay attention to where the cursor snaps and what constraints do or do not pop up when I use this. So I'll start the first endpoint here, and we'll get to the end, and you'll notice that it snaps to the end, but no parallel constraint is automatically inferred here. So just remember that. So if I go back and grab my endpoint, I can move my line, and there's no parallel constraint inferred there. So I'll just click undo. But next, what I'll do is I'll go back to Constraint Inference Scope, select all geometry, and press OK. Now when I create a line, and we'll reference it off this top one, you see it wants to snap to the endpoint. We'll let it. And then you already see down here in the middle, as I'm dragging this line down, it infers a parallel constraint automatically. And I can do that with any geometry found in the sketch plane because I allow it to. So if I drop that line, you'll see that it's automatically inferred that, that constraint there. And so you see that these two lines don't have it, but these two do. And if I move this, this other line moves with it. The final option within our Constraint Inference Scope menu is the Select option. And so to illustrate this, what I'm going to do first is I'm going to draw a line that's not quite parallel with these two lines here, but close. And I want to show you that I can infer constraints specifically off of whatever selected geometry I choose and nothing else in the sketch plane. So I'll just drop this line somewhere in here and get it close to the angle, but don't let it snap to anything else. Okay, so now I go back to my Inference Scope menu, go to Select, and I only want to infer constraints off of this line. I select that line, it turns light blue, I'll hit OK, and now it turns dark purple. It may be a little tough to see on screen, but when you do this on your own computer, you'll see that it changes colors to indicate that this is the targeted geometry for our inference. So now we have that selected. We'll go back to our line tool. And even if I come out here into space and get that to snap to the other line, it's not going to let me infer any sort of constraints like our parallel constraint with these two lines. But you'll notice it lets me infer that parallel constraint with that originally selected line that's now in that dark purple color. So we can drop it there, and there you go. It's now constrained as parallel, and we've completed that option. That concludes this segment of the Autodesk Inventor part creation module, where we took a look at the available 2D sketch constraints. Don't forget to like this video, subscribe to the channel, and turn on notifications to stay up to date on future content as it's released. And as always, don't hesitate to reach out and let me know if there's anything else you'd like to learn about or see on this channel. I genuinely appreciate you watching and learning from me, and I can't wait to make more helpful content like this for you in the future. Thanks for watching, and I'll see you again soon.